The energy of an asteroid is equal to 10,000 Hiroshima bombs. One such asteroid, a mysterious entity called Oumuamua, blasted through our solar system and rekindled the interest of the scientific community. Elon Musk, the great innovator of space technology, revealed that Oumuamua is back, and it's not alone. Musk claims that its hidden properties point to the existence of life in various star systems. This celestial being challenges our understanding of space and its potential inhabitants. In 1837, an unusual object reached a major cosmic milestone by passing the Sun at a distance of 1,000 Australian dollars. For more than a century, this object continued its journey unnoticed, moving towards our star. It wasn't until October 19, 2017 that humanity became aware of its presence, when an image taken by the University of Hawaii's Pan-STARRS 1 telescope revealed a faint streak moving across the sky at a constant speed, subtending an angle of about 6.2 degrees. During the day, it marked a historic moment as the first recorded interstellar traveler, originally named 1I/2017 U1 and later named Oumuamua, meaning first messenger from afar, in Hawaii. The discovery led to a worldwide initiative to study Oumuamua with telescopes. Astronomers, including those at the SETI Institute, have been eagerly watching the object for possible extraterrestrial signals. Oumuamua appeared as a reddish, cigar-shaped oblong rocky object, measuring up to 400 meters long and about 10 times wider. This aspect ratio exceeds that of any known asteroid or comet in our solar system. It was traveling at 196,000 miles per hour as it approached the Earth, which is 109 of the bullet times faster, indicating that it could not have been part of our solar system for all that time. At first, scientists could not determine whether Oumuamua was an asteroid or a comet. Comets are composed of ice, while asteroids are rocky. Scientists first thought it was a comet, but reclassified it as an asteroid after it passed the Sun on September 9, 2017. However, additional measurements showed a slight acceleration, suggesting it may be a comet. Oumuamua's notable feature was its regular brightening and dimming every 7.3 hours, indicating its rotation around its short axis. This rotation pattern suggested a more rigid and durable composition than the usually brittle snow-like material of most comets. Its dark red color, similar to that of some outer solar system moons hit by cosmic rays, may also contain iron, as suggested by University of Hawaii astronomer Dr. Meach. Despite these insights, the origin and nature of Oumuamua remains a mystery. Its trajectory has puzzled scientists, suggesting something beyond natural factors. Several theories have arisen to explain the identity of Oumuamua. Some believed it to be rock, while others claimed it was composed of gas. Amazingly, some experts even considered the possibility that it could be an alien spacecraft. This raises an interesting question. Could an alien mothership navigate our solar system and use smaller probes to study the planets? Dr. Meach speculated that Oumuamua may have drifted away from a distant star after a supernova explosion, or may have formed from the collision and merger of two objects. According to Elon Musk, astronomers were initially excited when they noticed that the trajectory was pointing in the direction of Vega, a bright massive star in the constellation Lyrae. Calculations showed that this entity could have traveled from Vegas to our location in about 600,000 years. However, the likelihood that Vega is the actual source has been reduced due to significant changes in its path. Oumuamua is thought to have first encountered our solar system while traveling at the speed of nearby stars. Another possibility proposed by nature is that Oumuamua could have traveled across the galaxy for billions of years. We are not sure of its future trajectory. Consider how the Voyager spacecraft got its speed from Jupiter. Similarly, Oumuamua receives momentum from the Sun and moves it faster and in a different direction. Dr. Meach explained that this asteroid, like its counterparts, will revolutionize our view of the galaxy. When you look at the stars, they seem distant and isolated, which is the opposite of what these asteroids reveal. They remind us that everything is connected and exciting. The oxygen and iron in our blood came from a huge explosion in a distant region. Gold objects such as wedding rings were formed by collisions of superdense stars, and some meteorites that fall to Earth come from asteroid collisions on Mars. It should be noted that some respected scientists speculate that these meteorites may have carried life from Mars to Earth at a time when Mars had a warm and humid environment. Life could start there and then travel to Earth with these meteorites. It's a bold idea, but legitimate astronomers are considering it. Our relationship to the cosmos can be traced even further back in time. Consider that Oumuamua could have been here for hundreds of millions of years. Although this may seem like a long time, it is only a fleeting moment on a cosmic scale. The Milky Way is approximately 10 billion years old. During this enormous period, Oumuamua is believed to have traveled through about 20,000 star systems, a modest fraction compared to the galaxy's 200 billion stars, but still an impressive number of cosmic encounters. Oumuamua would have trailed dust and particles, allowing the stars and worlds of the galaxy to intermingle. This indicates that the universe may be smaller in scale than previously thought, although it is not within our immediate line of sight. The solar system has not yet let go of Oumuamua. Elon Musk and many astronomers predict that Oumuamua will enter the Kuiper Belt around 2024 and cross its edge by the end of 2025. He estimates that it also exceeds Voyager's farthest point by 38 years. However, since Oumuamua has interested astronomers, they are making the most of the information gathered in just a few months to understand as much as possible about this fascinating interstellar intruder. Originally thought to be an asteroid due to its length of about 2,600 feet and width of 26 feet, Oumuamua behaved in an unusual way in its trajectory. Astronomers and scientists observed significant non-gravitational acceleration, indicating that forces other than gravity played a role in its motion. Dr. Meach explained that this acceleration could be caused by several factors. His team investigated at least 6 possible causes and dismissed some as improbable or inconsistent with observations. One likely explanation was cometary gassing, a common phenomenon in comets. Outgassing occurs when a comet approaches the Sun, causing its surface materials to directly change from solid to gas. This process gives the comet an extra push, changing its speed and rotation outside of the influence of gravity. This change in movement resembled the behavior of Oumuamua. Note the direction of the rising dust from Oumuamua. This became exciting because the gas of a comet usually carries surface dust with it. However, Dr. Meach claims that even if the comet lacks microscopic material, the presence of larger dust particles on its surface may have affected its speed. This thought kept the comet of thought alive. In addition, the researchers mainly observed visible wavelengths, which made it difficult to detect large dust particles. Therefore, no visible sign of dust from Oumuamua was found. The lack of gas warning signs was also confusing. Astronomers expected a significant amount of gas emissions to affect Oumuamua's speed in the observed way. Dr. Meach's team specifically looked for CN gas, a substance he says is bright and easy to detect. It acts as a proxy for water, which is difficult to detect. CN is often released from comets in our solar system along with water. Interestingly, despite their efforts, CN gas was not detected at their detection limits.
Because comets in our solar system can contain large amounts of water, the strong upper limit of the absence of CN gas indicated that this comet was chemically unique. Dr. Meach explains that if a large amount of water was released, it probably came from another solar system, which could explain this unusual discovery. Astronomers used the Spitzer Space Telescope to study Oumuamua in the infrared for more than 30 hours, trying to determine its thermal properties. However, they faced challenges in their mission. Dr. Meach explains that thermal infrared detects thermal radiation, and in this case, their observation did not yield significant results. Interestingly, even going unnoticed can provide insight. In this case, they concluded Oumuamua must be brighter than expected if it exhibits comet-like thermal behavior. An object's reflectivity, or how much light it reflects, can reveal information about its size, composition, and shape. They speculate that the reflectivity was similar to that of comets, which is very low, but they obtained a reflectivity of about 10% instead of the typical 4% for comets. So again, it doesn't really match the profile of the comet. For it to match the 4% reflectivity, it would be expected to have a very high thermal resonance on its surface, unlike other comets. This is another interesting quirk. Furthermore, the same infrared probes did not detect carbon monoxide or carbon dioxide leaving Oumuamua. This finding remained important because the Merch team considered the possibility that Oumuamua emits these gases in large quantities.